Two groups, treatment and control. The treatment group improved more. But what if the labels don't matter? What if you randomly assign patients to groups and still saw the same difference? The permutation test answers this. Shuffle the treatment and control labels randomly. Recalculate the test statistic, the difference in means, the t-statistic, whatever you're measuring. Repeat 10,000 times. This creates the null distribution, the distribution of the test statistic, and the labels truly don't matter. Now compare your observed statistic to this null distribution. If the observed value is more extreme than 95% of the permutation values, reject the null. The p-value is the fraction of permutations as extreme as or more extreme than the observed. No normality assumption. No distributional assumption at all. In genomics, permutation tests are the grand truth. GSEA and Limma use analytical approximations for speed, but permutation-based methods validate them. Gene set enrichment analysis permutes gene labels to build the null distribution of enrichment scores. In single-cell analysis, cluster validation often uses permutation. Shuffle the cluster labels and check if the marker gene patterns disappear. If the markers are still significant after shuffling, the clustering is meaningless. Cross-validation answers a different question. How well does the model predict new data? Fit the data into training and test sets. Fit the model on training data. Evaluate on test data. The test error is the honest estimate. K-fold cross-validation splits the data into K pieces. Each piece takes a turn as the test set, while the other K-1 pieces are training data. Average the K-test errors. Leave one out. Cross-validation is the extreme in folds, each with one test observation. Training error is always optimistic. The model has seen the data. A complex model can memorize every data point and achieve zero training error, then fail completely on new data. Cross-validation catches this. The sorting hat video used 5-fold cross-validation to evaluate classifiers, logistic regression, KNN, random forest. Here's what was happening behind the scenes. Split the patients into 5 groups, train on 4, test on 1, rotate. The model that performs best on average across folds is the one you trust. 3 tools, 3 questions. Bootstrap, how uncertain is my estimate? Permutation, is this result real or could it happen by chance? Cross-validation, how well does my model predict new data? One principle unites them. When you can't get more data, reuse the data you have. Resample it, shuffle it, split it. Each reveals something different about the reliability of your conclusions. You can't survey everyone, but the bootstrap extracts uncertainty from a single sample. Permutation tests build null distributions without assumptions. Cross-validation estimates prediction accuracy without new data. These 3 methods appear everywhere, from PopPK model validation to machine learning to gene expression analysis. The opinion poll is small, but the information it contains is vast.